A few months ago, we started a series of episodes to explain what is the quantum world like. Our goal was to try to understand what is the Higgs boson. Today, we are going to talk about the Higgs boson. And this is Montfrey, and this is your Cosmic Kingdom. On preparing this episode, I found a fantastic Jim Al-Khalili interviewing the Higgs himself. In a 120 seconds video, he explains what is the Higgs boson. I don't think I can do it better. So enjoy the video, and then I will try to give you my explanation.
It's the Higgs boson.
Well, like all in elementary particles, I think we field theorists think of it like Einstein thought of photons as just these particles are just packages of energy of some kind of field. And the feature which distinguishes this kind of theory, which leads to this kind of symmetry breaking, is the existence of what we theoretical physicists call the vacuum, which means nowadays something different from what it used to mean. It means just the lowest energy state that you can possibly have, in which there are no particles around, but there may be something around, and that something around can be a background field of some sort, which pervades the universe. So in this theory, there is such a background field, and the background field, in interaction with all the other stuff which goes through it, is responsible for generating the masses and mass differences of the other particles, elementary particles, the ones which are packages of energy of all the other fields, simply because the background affects the way the waves propagate. But then the field itself can be excited or classically to give you waves, and the packages of energy of that are the Higgs boson. So it's an extra which comes with this type of theory, that you need to have something there which is the excitation of the background field.
For me, that's a beautifully eloquent explanation of what the Higgs field is, what the Higgs mechanism is.
But not for most people.
So here's challenge number 2. Could
Okay.
you encapsulate that explanation in, say, 30 seconds?
No.
We've been talking about fields, which are things that permeate this space, and these fields normally have a carrier, and these carriers are particles. So for instance, for light, the carriers are photons. For gravity, we believe there are going to be gravitons, and for the other fields it's more complicated. So what Higgs postulated is that there is a field that is called the Higgs field that permeates all reality, and that field is what gives particles mass. Without that field, we will be massless, and probably the universe won't exist as we understand it now. So it's important to explain why certain particles like the photons don't have mass, and others like protons or quarks, if you prefer it, have mass. This is because the Higgs field. And the particle carrying this field is the Higgs boson, in the same way that the particle carrying the electromagnetic field or the light is the photon. So the difference is the mass of the Higgs boson was so big. Well, if you compare it to everyday objects, it's small, but it's so big that we needed a huge particle accelerator to be able to create that amount of energy, to be able to create that particles. And I hope I managed to explain it, and I will leave it here for today. I hope you enjoyed this episode, and see you guys next week. Bye bye.